Hi there. Today we are going to factor out a GCF from different polynomials. So a GCF, just a reminder, it stands for greatest common factor. So before we really get into factoring out the GCF, let's talk about what that could be with these different terms. Let's see here. With letters instead of just numbers that you may have seen in your previous math classes. Okay, so this first one here, let's write it out. So x cubed, we know from last chapter, it's 3x's. This one is 5 of them. Okay, if I want to take out anything they have in common, I can take out, okay, there's 3 here, there's 3 here. So x to the third, or 3x's, 1 times 2 times 3, that's my GCF between those two terms. Okay, let's try another one here. I have 4 y's. I have 1 y. I look at both of them, what they have in common, they both have 1 y. So 1 y is my GCF. All right, let me show you when we have multiple letters here. So I have 3 z's, okay, 2 d's, 5 z's, run out of room here, 1 d, 2 y's. Okay, so let's circle anything they have in common. They both have, let me change that to red, sorry. 3 z's, okay, 1, and then no y's. Okay, so my greatest common factor would be z cubed, and then e. Okay, so let's generalize this a little bit and see, you can kind of see the shortcut here. Between these two, my greatest common factor is x cubed. Between these two, it's y. Here, if I look at my z's, my greatest common factor for z is z cubed. Look at d squared and d, my greatest common factor is just d. So you may notice a pattern here. Yes, you are correct. The greatest common factor is the lowest exponent between the two. So 3 is lower than 5. 1, there's an invisible 1 here, is lower than 4. That's why that's my GCF. And then here I have to just do it as many times as I have letters. So let's look at that a little bit. See if we can do this a little bit faster. All right, so next one here, we have a to the 4th, a to the 7th. This here, 4, that exponent is less than 7. So that's my GCF for the a's. Look at my b's. I only have a b here. I don't have anything in the first one. So that can't be taken out of both of them. So that's not included in my GCF. Okay, next one here, let's look at my n's. I have n to the 4th, n cubed. N cubed is the lower amount. That can be taken out of both of them. And if I look at my m's, I have m squared and just plain m. The smaller one here is m. That can be taken out of both. That's also included in my GCF. You can write it like this, or you can write it m times n cubed. Doesn't matter which way. Usually they write in alphabetical order, so A, B, C, D, whatever one comes first. Okay, then last one here, let's have our k's. So I have k squared and k. My lower exponent here is that invisible 1, so it's just a k. My j's, I have j cubed and just a j. And I have p to the 4th and just p. So my GCF is just 1k, 1j, 1p. All right, so it says, what do you notice about the GCF? We kind of talked about this a minute ago. We're saying, okay, the GCF is the letter with the lower exponent. So say for each variable. Okay. So example 2, let's factor out the greatest common factor from this two-term polynomial, which would be a binomial. So what I'm going to do is I'm going to draw a line under each term, and that's what I'm going to divide by. When I factor out, this is the same thing as dividing. So that's why I have these division lines. So first thing I'm going to do is look at my numbers. So I have 27 and 15. The greatest common factor between those two numbers is what we have to start with. So over here, let's write these out. Those of you might be able to see this right away. Oh, okay. The GCF is whatever, but let's start slow in case we don't see it. So I'm doing the good old factor tree. Some of you may have done this before. When you get down to all prime numbers, so 3 is prime and 5 is prime, you're done. So to find the GCF, you just circle anything they have in common. So they both have a 3, and that's it. So my GCF for these two numbers is 3. Okay, so I'm going to take a 3 out of both. And let's look at my A's. I have a squared and just 1a. We know from up top here that I take the lower exponent, so that's just a. All right, now look at my b's. I have 1b and b squared. This guy's lower. I just take out 1b from each. Okay, and then I have a c over here, but nothing here, so I can't take out a c from both. That's not a common factor, not common between the two terms. Okay, so now I'm going to write 3ab over here, and I'm going to put these parentheses. So I'm going to have two terms written here. The first term is what's going to be when I divide this. Second term is when I divide this. Okay, so I have 27 divided by 3 would be 9. And I have a squared divided by a. So this is last chapter. When I divide exponents, I have to subtract. So just a reminder, we have a little invisible 1 here and here. Draw those in. So I need to subtract 2 minus 1. That just gives me a. And then my b's. I have b to the first over b to the first. That just cancels and there's nothing left. So I'm just going to, not write anything. Okay, then I'm going to put my plus sign here because it's still positive. 15 divided by 3 would be 5. And then a to the first divided by a to the first, those cancel. B squared over b to the first, I subtract. So 2 minus 1 just gives me a b. And I have a c on top, but no c's on the bottom, so it just stays c. Okay, so then I'm done. I factored out my greatest common factor, and this is the most simplified version we can have left in our parentheses. So let's look down here. It says, how can you check your work when you're factoring out a GCF? So this is a way you can make sure that you did it completely correct on test or quiz. I'm going to distribute it back. So I'm going to recopy this, 3ab and then 9a plus 5bc. Okay, so we've done this, in our past section here, I'm distributing. So I'm going to do 3 times 9 is 27. A times a, I'm adding my exponents. So that gives me a squared. B times, there's nothing else, it's just b. All right, then second one, I have 3 times 5 would be 15. A to the first times nothing else, it's just a. B to the first times b to the first, I add those exponents. And then the c is right here. So let's look at our original problem. Up here, that should exactly match. Perfect. Okay, so this here matches this guy here, so I know I'm correct. The purpose of this is factoring out GCF. You'll see, especially in later sections, this is how we're going to solve problems because we have things multiplied together. This is much easier to work with than this format. Okay, so let's go in the back and do a couple more of these. Okay, so next one here, we're going to draw our division signs and find our GCF between these two numbers. So I'm going to start by doing my factor trees. So now let's circle anything they have in common. So I see they both have a 2 and a 3. They also both have another 2. So my GCF is 2 times 3 times 2. That would be 12. So if you saw, oh, I think it's 6, and you went with 6 right away, not a big deal, but the end, you're going to have to take out another 2. Okay, so sometimes it's easier to do the factor tree to start out with. Okay, so I'm factoring out a 12 from both of these. Now, this is a little bit new because there's a negative sign in before the first term here. When this happens, you want to take out the negative then. Okay, let's look at my a's. I have a to the fourth a cubed. My smaller of the two is a cubed. And then I have b squared and b. I'm just going to take out a b. Okay, so let's write negative 12a cubed times b and then my parentheses. So I'm going to do negative 36 divided by negative 12. So that gives me a positive 3. A to the fourth divided by a to the third. I subtract 4 minus 3 is a to the first. And then b squared over b would just be 1b. Okay, and then we have 60 divided by negative 12. So that's a negative 5. A cubed over a cubed, those cancel. B over b, that also cancels. So that's all I'm left with. I'm going to move this parenthesis over here a little bit to make it look better. Okay, so if you look in this part of the parentheses, if the numbers, say you had 6 and 10 left here, because you didn't take out the right GCF, then you would say, oh man, and you'd have to divide out a 2 again. Okay, we did it correctly. I'm just showing you in case you use the correct GCF, the biggest GCF to start with. Okay, so this here is my final answer. This part's the greatest common factor, and this is the reduced part in the parentheses left over. Okay, let's try C. This one's actually a little bit easier, even though there's 3 terms. I'm going to draw my line, my division line under all 3 terms. Between 2, 20, and 6, my GCF is just 2. I have a 2 for all those. Then I look at my x's. I have x to the fourth, x squared, and x. This is my smallest one, so I can take it out of all 3. Because remember, factoring just means you're dividing out. I'm dividing all 3 of these terms by 2x. Then I'll have my parentheses. So the first part here, I have 2 divided by 2 is just 1. X to the fourth divided by x. Subtract those exponents, so I'm left with x cubed. Here I have 20 divided by 2 is 10. And then x squared over x is just x. Last one here, I have negative 6 over 2 is minus 3. The x's cancel, so I just have minus 3. Okay, and then we're done. That's my GCF, my 2x. And this is the leftover polynomial. Okay, let's skip down here to F. We'll just do a couple more. Okay, so F here we have 3 terms. Look at your 3 numbers, 24, 24, and negative 6. I'm going to take out a 6 from all 3. That's my GCF, the biggest number that goes into all 3 of them. All right, and then my ends. I have end of the fifth, end of the third, end of the third. The smallest is end of the third. And then my m's. I have m squared, m, and then nothing. So I don't take out an m because this last guy here doesn't have one to take out. All right, so I have 6n cubed. First, I'm going to divide 24 divided by 6 is 4. End of the fifth over n, the third is n squared. And I still have my m squared. And then 24 divided by 6 is another 4. My n's cancel this time. I just have an m. And then negative 6 over 6 is minus 1. The n cubes cancel. Check the parenthesis part. Make sure there's nothing common in all 3 of them, and then you know you're done. All right. Let's do feel like I looks kind of crazy. Let's do the last one here. Okay, so let's look at our GCF between these 4 terms. Okay, so we have 6, 54, 30, and 30. Let's check. Does 6 go into 54? Yeah, 6 times 9. And then 6 goes into 30. Yeah, 6 times 5. So that actually was pretty easy to find our GCF. All right, next, let's start with my x's. I have x to the 6th, 4th, 6th, 4th. Smallest one is x to the 4th. All right, then my y's. I have y, y squared, y, y. Smallest one is just y. Okay, and then z's, I have z the 7th, 8th, 3rd, 4th. Smallest one is 3rd. Okay, so I will divide these out. So I have 6x to the 4th y times z cubed, and then by parentheses. So I'm dividing the first one here. 6 divided by 6, that cancels. 6 minus 4 is x squared. Y's cancel. When I subtract the z's, you should get z to the 4th. All right, next one. 54 divided by 6 would be 9. My x's cancels. When I subtract my y's, I get just 1 y left. Z to the 8th divided by z to the 3rd would be z to the 5th. Next one, negative 30 divided by 6 is negative 5. When I subtract my x's, I get x squared. My y's cancel, and my z's cancel. All right, and last one here, I have 30 divided by 6 is positive 5. My x's cancel, my y's cancel, and I have 1 z left. Okay, check here, make sure nothing's common. To see, oh, they look like they have z's. Oh, but not everyone. So I did the correct thing. This is my GCF. Everything left here doesn't have anything common between all 4 of them. Okay, and there you have it. We are now factoring out a GCF. Nice job today.